My dear friends, as transformer protection is yet pending, there will be around 10 videos, and I have given to you 3 videos. But I am awaiting the artwork, the figures, and therefore in between there will be some 15 videos of transmission line protection by overcurrent and earth fault relays. Transmission line by overcurrent and earth fault relays complete chapter with questions and everything is available in module 3 of Adapt Me, which can be downloaded from Google Play Store. But it is paid. And now it is available all throughout the world. The fee is rupees 550 rupees, but it seems people are not paying. Maybe probably people are not interested in the topic. Anyway, but there may be people who are interested. So I am repeating the same thing which is in module 3, payable. I am repeating free of cost on the you Adapt Me channel of YouTube. So you can get this free. So transmission line protection by distance and carrier current, which are higher. I mean, carrier current protection is the best, or so to say, the line differential protection is the best. Distance is better because it is used in 132 kV and 220 kV lines. Overcurrent and earth fault protection is usually used only up to 66 kV, but it is used as backup in 132 kV, 220 kV, 765 kV also. So it is not useless. It is very useful. 11 kV, 6.6 kV, and 66 kV. It is the only protection that is used because it is economical and feasible. You see, for 66 kV lines, you cannot go for distance relaying because it is very costly protection. So how, I mean, what is overcurrent and earth fault protection? How to set the relays? How to procure the relays? How to prepare the specifications? And what are the facilities available in modern numerical overcurrent and earth fault relays? That will be covered in these 15 sessions. Each session more or less of half an hour so that you can easily go through. And I would request you that just open the video and see it for 2 minutes and then give me like in LinkedIn or Facebook. Does not serve my purpose. I would request you to see the video fully for half an hour. I am sure that you will get quite a good of knowledge. Most of the industry persons also will get quite a good of knowledge, because as far as I have seen, all over India, I do not talk about other countries because I have no experience, but at least all over India, no state or no engineering college is teaching power system protection to this depth. Probably they may have restrictions of time, they may have restrictions of syllabus, whatever may be the reason, but people are not teaching to this depth. And unfortunately, this is required in the field practices. That you will surely agree once you hear my videos. So I would request you not just have a look to the video, or probably so often I'm sending the video in LinkedIn. I'm rather putting it up in LinkedIn. And people, for the sake of respect, like, that does not uh, mean anything. If you hear the videos for full time, then you will get knowledge, and I will also earn view hours. 4,000 view hours is my uh, uh, target, and it is only 1,000 view hours. Some 60 videos are already on Adapt Me YouTube channel. So with that, I start transmission line protection by overcurrent and earth fault rays from scratch. That means uh, many industrial friends may be knowing many things, but this is for students too. So I start from scratch. The demand of electrical power is increasing day by day at a very fast rate. I have often told that in Gujarat, I know that on 1st May 1960, the installed capacity was 250 megawatt, and today it is more than 25,000 megawatt. So demand of power is increasing day by day. And obviously, when demand of power increases, you need many generators, many transmission line network and distribution network reaching out to the urban and rural areas in the corners of the small villages also in the country. And because you have to transmit at a long distance, the transmission voltage is reached to 765 kV and not 765 kV, even 1200 kV. So transformers and other equipment so up to 1200 kV are required, and the relevant problems are also required to be studied. No doubt, I will not be going through all these things because that is a part of high voltage engineering. Here we will be talking about protection only. So when you are transmitting power from one end to the other, you have to uh, uh, protect the transmission line, as I told you, up to 66 kV we will be protecting uh, by overcurrent and earth voltages. But the very important thing, the requirements: speed, discrimination, selectivity, and reliability. So out of that, speed and selectivity contradict, because selectivity means only the least faulty portion should be isolated from the remnant of the healthy section. So the other healthy section is sensing the fault, but it has to wait, and wait means time. Time means speed is lost. Selectivity is there, but speed is lost. So speed and selectivity are contradictory. The modern numerical relaying has given solution to this also. Uh, the modern numerical relays had addressed this problem. Slowly we will see all these things. Uh, as I told you, up to 66 kV we are using overcurrent relays. For 132 kV, 220 kV, and further we are using 132 kV and 220 kV. We are using distance relays, but backup overcurrent and earth fault is there. 400 and 765 kV usually line differential relaying is preferred, but once again backup distance or backup overcurrent and earth fault is there. So overcurrent and earth fault is throughout up to all voltage levels as a backup. It is there. 66 kV it is as a main protection. 11 kV it is as a main protection. So we will discuss about these things now. So first we will start the very, so to say, uh, simple network radial feeder. And such radial feeders are there because at the end when you feed it is radial. power is coming up to 132 kV in interconnected system. But from 132 kV to 66 kV, 66 kV to 11 kV, and 11 kV to 11 kV by 415 volt transformers, and then to final consumers is going through radial feeder. I mean, at consumer end, there is no source. No doubt that things are now changing at consumer end also. Now people are having the generation. Many industries are having their own generation because electricity so often fails, and their production is rather hampered. Their production gets reduced. So they have their own diesel generators or gas turbine generators or whatever. We have on the seashore near Madras and Porbandar, where the wind velocity is there, in Saurashtra region, we have got very many windmills. Also, now government is giving subsidy for individual consumer, individual layman, residential person, that you can on your terrace, you can have a solar power plant, smaller power plant, which can feed your house. It cannot feed uh, the society or a city, but which can feed your house. But then it is power, it is source. So source at the load end is not there, is slowly becoming uh, rather obsolete. And when these things come, the protection becomes complicated. So I'm yet not talking of that protection. DGs, distributed generation, protection with distributed generation, I'm yet not talking. Protection with distributed generation is yet a topic of research. Right now we are assuming that the source is on one end and load is at the other end. That is radial feeder. So here something is written. Rather than reading these things, I will read the figure, and figure will tell everything. We are producing power set 15.75 kV. The generation voltage is 6.6 kV, 11 kV, 13.8 kV, 15.75 kV, 22 kV also, right? But I am taking one typical voltage 15.75, 210 megawatt. One unit generating 210 megawatt. One unit can generate 120 megawatt also, can generate 500 megawatt also, and can generate 660 megawatt also. I am taking 210 megawatt. Usual design power factor is 0.85. I cannot transmit power at 15.75 kV because then I would need very large transmission conductors, maybe half a meter diameter or 1 meter diameter, which is not feasible. It cannot be stringed. The sag will be very large. I mean, that is just technically not feasible. And also, if you reduce the area, then I square R losses will be high and efficiency of transmission will be bad. Therefore, I have to step up. So, the day on which the transformer was invented, the scenario of electricity changed. And now we are stepping it up from 15.75 kV to 220 kV. Right? 250 MVA. GT means generator transformer because it is affiliated with generator, connected with generator. It is a simple power transformer. Between generator and generator transformer, there is no breaker in unit system of generation, because if you have a breaker, its breaking capacity required will be very large because only generator reactance. And if you think of the worst condition, then the subtransient reactance of large generator is 20%. That means 5 times the rated current is passing during first cycle. So the breaking capacity is very large. Rated current is also 9050 ampere if you calculate. So some 10,000 ampere. It is technically not feasible to have a generator, a breaker there. No doubt, such breakers are there. That is non-unit system of generation. So right now I am not talking of non-unit system. I am talking of unit system. So between generator and generator transformer, there is no breaker. Between generator transformer and infinite bus, there is breaker 52G. And as we have talked in generator, you see, generator does not give 210 megawatt to consumers. It eats away 10% of power that we have talked in generator, because you have to run the boiler, turbine, you have to run boiler, feed pump, ID fan, FD fan, PF fan, many things. It's a big business. Generating plant is a big industry. Many people, some 500 people are working there. If there are 5 or 6 or 7 plants, there are many people, many engineers. One chief engineer is in charge, or rather is the head, and under him there are many superintending engineers, many executive engineers, many junior engineers, deputy engineers, many uh, uh, the working skilled staff, unskilled staff, Mazdoors, you see, many people are required. So it's a big business. But that business we will talk when we talk about power generation, not now. But that business is here shown only by a circle and an AC sign. It is not that easy. Now 52G is there. That is disconnecting the generator and GT from the bus if the fault occurs in generator. Or if the fault occurs in line, generator is feeding the fault. Therefore, generator has to be disconnected. And if you want to maintain, then also you have to disconnect the generator breaker 52G. 52 is a standard NC number given to breaker, right? These numbers are given in my book. I have published a book published by Tata McGraw-Hill. Now probably it is known as uh, uh, Tata Education International. So it is an international publishing group, and they have published my book. And in that, in the last pages, I have given 1 to 100 numbers. You see, because you write generator, here I have written generator in English, but you may not expect Tanzanian engineer or Brazilian engineer or Swiss engineer or Swedish engineer or Czechoslovakian engineer or Syrian engineer to know English. So everybody should know 1 to 0 English numbers and A to Z. So if you write 52G, he will understand that you are talking about generator breaker. Right? Similarly, 2 is for timer, 27 is for under voltage relay, 51 is for time delayed overcurrent relay, 50 is for instantaneous overcurrent relay, 21 is for distance relay, 29 is for isolator, 98 is for pole sleeping relay, 99 is for fluxing relay. Like that, standard numberings are done by I decided internationally so that everybody will understand. And in drawing also it is easier to write 52G, rather than writing that big thing generator breaker. So that terminates on 220 kV infinite bus. From there many lines are emanating. I have shown 3, but not necessary 3. There may be 10 lines emanating. Out of that, one line, 220 kV line, is going to the 220 by 66 kV. I mean, that's going to 220 kV bus, and that is receiving substation. And there are 220 by 66 kV, 100 MVA. transformer. Substation engineering is a different subject, and that we are taking in paid classes. Also, in module 2 of my power system protection module, uploaded on Adapt Me, which you can download from Google Play Store. You have to pay and understand what is substation. So substation does not mean only breaker, transformer and breaker. There are many other equipments, but here I am not showing. I am reducing voltage to 66 kV. You see, now this is also a point, that how do you decide the voltage of transmission? Voltage of transmission is decided by the power, amount of power that you want to send from one end to the other, and the distance from one end to the other. If distance is high and power is high, then you have to go for higher voltage. The uh, curve of cost versus voltage is is not a straight line curve. It is a curved, I should say, what should I say? Uh, Concave towards upside and convex towards downside. Towards XY axis, it is convex. So there is a minimum voltage, minimum economical voltage at which you have to transmit. Instead of 220 kV, I might have to transmit at 400 kV also. Here I have taken 220 kV as one assumption. But as one assumption, or here 220 kV is economical, but it can be 400 kV also and 765 kV also. But anyway, 220 kV was economical there, but now my distance of transmission is hardly 50 kilometers, and 10 lines have gone, so out of that one line power has also reduced. So now my economical voltage is 66 kV. So I need a substation, which is known as receiving substation. Receiving substation means a substation which receives power from generating plant. So there I have got a transformer 220 by 66 kV. If the next voltage is 132 kV, it could have been 220 by 132 kV. And then once again one more substation 132 by 66 kV. That depends. So here I've assumed like this. So from 66 kV bus, once again some 10 lines are emanating, and one of the line is going to 66 by 11 kV distribution transformer. That is a distribution substation, because therefrom the power is distributed. So up to 66 kV it is transmission voltage. 11 kV is not transmission voltage. 11 kV is the uh, distribution voltage. So we have got a PMT, pole mounted transformer or distribution transformer, right? The typical capacity is 25 MVA. At receiving substation, I've taken typical capacity 100 MVA, right? So that 11 kV feeder is going to distribution transformer. Now distribution transformer has to be protected, because everything has to be protected, because distribution transformer and then for 15-volt consumer, then all consumers like me, you in residentials, commercial complexes, shops, municipal authorities, uh, the small scale industries of for 15-volt rating. So all these are consumers. So if nothing happens, there is no fault, then power will be flowing like this. But faults are inevitable. So regular flowing of power is not our subject. Our subject is based on faults. That means faults are bound to occur. You cannot avoid fault. You can do something. You can take a remedy when fault occurs, but you cannot avoid faults. So 415-volt distributor is there also the fault can occur. So that fault is rather protected by a KitKat fuse, normal KitKat fuse, which you would have seen in your house also. Or nowadays people are using MCCB, molded case circuit breaker, which is available from 100 ampere to 4000 ampere rating and 80 kiloampere breaking capacity. So that MCCB will protect if there is a fault in distributor. But if there is a fault in transformer itself, then DO fuse, dropout fuse is there. Dropout fuse means uh, it is a wire of low melting temperature, and that wire is passing through a porcelain tube, and both are connected. If there is a fault, then wire will melt and tube will fall down by its gravity, and therefore the arc will occur, but arc will be lengthened and it will be quenched. Um, if you see the full mounted transformer now, probably I don't know, because the porcelain tubes are out of stock, so they use the stone, simple stone available in streets, and and use that stone, so that by the weight of stone the wire will come down when it melts. So diofuse is for protection of internal faults in distribution transformer. Distribution transformer, you cannot use anything else, because 500 kVA transformer I had purchased at BVM, my engineering college, it was of 3 lakhs of rupees. And it is said that you can spend 5 or 10% of the cost of equipment to be protected for protection. So if I want to protect a transformer of 5 lakhs of rupees, I can use 500 rupees, right? Sorry, for 5,000 rupees, 10%. So in 5,000 rupees, I cannot get CT, I cannot get relay, and I cannot get breaker. You see, these three things are required, because when in other lines, if you see some 1000 ampere or 500 ampere is flowing, 500 ampere cannot be passed through relay. So you need a CT, current transformer, which will step down from 500 to 1 or 500 to 5, right? Then relay will sense the fault. It will operate, but it cannot break the circuitry. So it has to give signal to the breaker. R3 will give signal to its own breaker. So this is R3 will signal to its own breaker. And that faulty part will be disconnected from rest of the LD line. Right? That is what is happening. So in protection of large line, 11 kV, 66 kV, because 11 kV is feeding not only one pole mounted transformer, it is feeding 10 pole mounted transformer. So 5 lakhs into 10 means 50 lakhs, right? So now you can spend for CT, relay and breaker. So CT, relay and breaker are required for 11 kV feeder, 66 kV transmission line, 132 kV transmission line, 220 kV transmission line, 765, 1200 kV, whatever. So what happens is this, that if the fault occurs in 415-volt distributor, then the MCCB will operate and it will isolate the faulty section. So remnant LD section will work. I mean, other pole mounted transformers are fed by power. Only some small area, say 1 or 2 or 5 or 10 societies, will not get power. But the whole city, it will not be so that whole city or the whole uh, taluka or the whole district will not get power. ऐसा नहीं होगा.
That cannot happen. That should not happen. In right protective system, selectivity means minimum faulty section should be isolated. But say if MCCB fails, because if there can be a fault in 415-volt distributor, there can be fault in MCCB also, because it is also man-made. So if it fails, then relay R3 will give backup. This is known as remote backup, right? This is not, because backup are also of many kinds. We will see one by one, because at the time we cannot see. We have seen relay backup in uh, generator protection, generator reverse power protection. We are using 3 relays, 2 low forward power and 1 reverse power, because it is very important. So triplication of relays, and not only relays, the CT core feeding the relay is also different. So we are spending a lot, because we are uh, protecting some 1100 crores of rupees of transformer. Here the cost is not that much. So R3 will give backup if MCCB fails, because R3 is sensing. R3 is sensing. So now our question is, if there is a fault in 415-volt distributor, MCCB is also sensing the fault, R3 is also sensing the fault, but R3 should not operate and MCCB should only operate. So how will you discriminate this? So we will start with discrimination of fault location. Similarly, if there is a fault in 11 kV feeder, primarily R3 will operate. R3, which was backup to MCCB when the fault was in 415-volt distributor, is now primary protection, main protection for 11 kV feeder, fault in 11 kV feeder. And try to understand that this is a single line diagram. All lines are 3 phases, right? So R3 does not mean single relay. R3 means 4 relays, group of 4 relays. One relay for R phase, another relay for Y phase, third relay for B phase, and one relay for ground fault protection. So R3 means 4 relays. But R3 will operate and R2 will give backup. Before R2 will give backup, transformer relay will also give backup. But right now we are not studying transformer protection. Transformer protection is going on. 3 sessions are over, and then we are going to complete transformer protection also in time to come, right? But we have seen transformer overcurrent and earth fault trends on secondary side. That will give protection, I mean give backup to R3. And to that R2 will give backup, rightly speaking. So whole protection is like that. But I have to take in piecemeals, because you see, I cannot take everything at a time. Slowly you have to understand protection as a whole. So R2 will give backup to R3. And if there is a fault in 66 kV line, then R1 will give backup to R2. If there is a fault in 220 kV line, R1 will operate. And generator transformer backup overcurrent relay will give backup to R1, right? Which is not shown here, because I am not talking about transformer now. So this is all about the transmission line protection for a very primitive feeder. I'm telling primitive because the system in any state, Gujarat state or Maharashtra state or in any region in the world, is very complex. It is 11 bus system or 15 bus system, and there are some 100 transmission lines and 200 relays. And to set these relays is a big business, and probably so often you cannot do it manually. You have to design some algorithm, computer algorithm, and using that computer algorithm, you have to calculate the relay setting. But to go to that complex part, it would take time. Some complexity I am bringing here in these sessions, you will see. and you are going to find difficult to understand also. But right now this is very primitive, very primitive. So now you see, if I want to study this every time, every now and then I have to draw this figure. So I am simplifying this figure. I am removing transformer for simplification. Really it is there, but I am removing transformer from this figure. So this is all what I told. And last line I am writing, for this purpose we draw a simplified figure, that is 7.2. Right? At B there is transformer, but I have not drawn. So now AB is one line. Not that does not mean that from A only one line is going. From A 10 lines are going, but I have not drawn. And this is a single line diagram. So one line is 3 lines, RYB. So R1 is 4 relays, R2 is 4 relays, R3 is 4 relays. That you have to understand. A, B, C, D are the buses. And then there is MCCB or fuse, and then it goes to load. Now, my problem is, what is my problem? My problem is how to discriminate where the fault occurs. You see, if there is a fault in the load side, distributor side, then MCCB is sensing and R3 is also sensing. But R3 has not to operate, MCCB has to operate. And if MCCB fails, then R3 has to operate. So all these complicated things, how will it happen? How will the relay decide, sense that the fault is not in my region and in some, I mean, region of some another protective device? Similarly, if the fault occurs in line B in CD, then R3 has to operate, but R2 will sense. But R2 has not to operate. If R3 fails, then only R2 has to operate. When I teach the students, I so often do this joke, technical joke, that in this radial feeder, which is the first relay that will operate if there is a fault. So obviously students will say R3. On load side, if the fault occurs, R3. Then which relay will operate? Students automatically tell that R2. And then they tell R1. So first R3 will operate, then R2 will operate, then R1 will operate. This is wrong. If R3 operates, fault is disconnected, fault current is 0. Now normal current is flowing. So there is no question of R2 operating. So this joke I am so often doing with students to make them know, to make them understand that they should understand protection fully, not with half-heartedness. When I was teaching in 1986 to 2000, and more or less up to 2012, it was golden period. Students were hearing each and every word of mine. They were asking questions also. And uh, uh, laboratory was very rich. We were doing some 62 experiments. 62 experiments cannot be done in regular time. So I was taking extra sessions. And out of the class of 60 students, 40 or 45 students were coming to extra sessions. Now, when I'm going to PDP and Nirma, they are not ready to hear. They are not hearing. They are sitting in the class, but they are somewhere else. Our Osho says that you want to see your girlfriend. आपकी गर्लफ्रेंड को प्यार करने के लिए आप जाते हैं. But then when you meet your girlfriend is no doubt physically she is there, but mentally she is with her boyfriend, some another boyfriend. And that boyfriend is with some another girlfriend. So no student is hearing me. A student passed in 1990 under me. Now he is in Adani, and I asked his salary. What is his gross salary? He told that I have been a stamp paper sign is taken that you will not disclose your salary to your wife also. That means it must be some 60 or 70 crores per year. That student was saying that I'm taking interviews of 5 students every day. And I ask very simple question that this fan, ceiling fan, which is in your house, in his cabin also ceiling fan is there. So he shows the ceiling fan. Whether it is 3-phase or single phase. Be electrical past student from some university. He says that I don't know. That student should be thrown back to first standard. Start again and made to study up to BTech or MTech. Such students we are getting in these times. Be your BTech student. Or by chance some student notes that it is single phase. Then he asks that single phase fan or anything single phase induction motor cannot start by itself. It cannot rotate. So how do you rotate it? How do you give it a starting torque? He does not know that. Be electrical. And we are talking of going to Moon and Mars. We are talking of robots who will do all work. We are talking of many more complex technologies. But students are yet in first standard. So this is a big satire and so to say a very big allegation of mine. I have told this allegation to PDPO and Nirma is #1 college in Gujarat. That those students are also in standard 1. They are not in B. They are not in B. So this is an open platform. Somebody may read this video. Somebody may not hear this video at all. No worries. I like to make a video, so I am doing. I am satisfying myself. Whether you are satisfied or not is your question. So this is the condition. Very complex things people are not understanding. This is very primitive, but you will see that this is also difficult to understand. So how can I discriminate? So I have to find some quantity to discuss, some electrical quantity, obviously, because this is electrical. Some electrical quantity to discriminate. Some electrical quantity to discriminate whether the fault is in line CD or BC or AB or in load side. That I have to do. So let me see. Probably that is not there on today's slide. Yes, that is not there in today's slide. It must not have been half an hour also, right? I wanted to take from scratch, so it has taken some time. But I earnestly request, very earnestly request to all my friends, and I've started getting uh, likes and followers from foreign countries whom I don't know, and from India also whom I don't know. My students do love me, so they will like me without even seeing video, or just if they see that Oza sir has put the video, they will like it. That is a different thing, because they are my lovers. Because I have taught them for uh, 50 hours regular and another 50 hours extra. So every semester I have rather taught them for 100 hours, and I have taught them for 3 semesters. So I have taught them for 300 hours, free of cost. Whatever college gives me salary, in that salary I have done. So they will like, my lovers will like me. But I am seeing that those who are not knowing are also finding the things interesting. Things are really interesting. Subject is very logical. Subject is very interesting. If you go through, you will understand many things. probably you would not have understood these things in your universities. Even today, the universities are teaching electromagnetic relays, which Akbar was not using. He was denying. Akbar was telling that this is too old a technology. Akbar, Humayun were telling that this is too old a technology, which the teacher of today is teaching, that disk type relay. I have so often told that one Mr. Tukaram, who is hardly 10 years or 5 years younger to me, I am 72, he must be 67 or 65, very old person, so old-minded. He came to BVM, our college, to uh, rather see the syllabi and to give comments on the syllabi, whether because BVM became क्या बोलते हैं उसको, it is self, they have their own, uh, their university by its own. They, it is not uh, um, rather affiliated with any university. So BVM has its own syllabi. So he came and he, by the time, by chance, he had seen the syllabus of measurement. And in measurement, there was a chapter of energy meter. And he read the word in the syllabus, creep of an energy meter. Creep means if current is not there, disk should be stable. Because if current is not there, subscriber is not using any electricity, it should not be charged. If disk rotates, then the resistor will charge. So to allow, I mean to stop the disk, there is some mechanism that is known as anti-creep mechanism. So for that, because I was in meter industry for 3 hours, for 3 years, and we were manufacturing 600 energy meters, 600 single phase energy meters daily, or 250 three-phase energy meters daily. And uh, it was, I mean, the energy meter had, it was an inventory of 1500 parts, and all 1500 parts were passing under my eye. If I pass, then only they will be used, otherwise not. All 1500 parts. So it was a big business. But creep was there because it was analog energy meter. That Mr. Tukaram, 67 years old, told my told the person was told the head of the department, Rasesh Mehta, that Rasesh, you go to your house. Does your energy meter creep? You see your energy meter. Your energy meter is now digital energy meter. There is no disk, and if there is no disk, you should not teach energy meter, analog energy meter in your syllabus. And class 1 institutes are yet teaching this. I am very much against this. So, my friends, technology is advancing very fast. Keep in tune with technology. AdaptMe is trying to uh, serve you the latest technology, whatever latest I know in power system protection. I am trying to serve at no cost. You have to simply go to AdaptMe in YouTube and see the videos. And once you see the videos, there are 60 videos put up of mine. I have covered distance protection, line differential protection, generator protection. Many protections are covered. Now I have started transmission line protection by overcurrent and earth fault relays. Then I will complete transformer, then induction motor, then bus zone protection, then CTPT, right? And then I'll go to circuit breakers and then over voltage protection. There will be more than 100 videos of half an hour each. So, or maybe some videos maybe 45 minutes. So it will be a work of some 60 hours. So
please stay tuned with Head Up Me. And I cannot meet million persons. I cannot meet 100 million persons. I am seeing on YouTube that some person, no doubt, is a musician, A.R. Rahman or Muhammad Rafi, or maybe Muhammad Rafi has died, but Shreya Ghosal has 10 million viewers because music is liked by everybody. This file system protection, nobody will, I mean, very, very small public will see. But at least I think 1 million is possible. 1 million is possible, but not by me alone. You should talk to at least 100 other people who are known to you, who are engineers, who are serving, and request them to बंद करो, request them to read the request them to uh, read the videos. I mean, hear the videos so that my uh, 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 work hours, right? The view hours increases, number of view increases, number of subscriptions increase, number of likes increase. That gives me, uh, I mean, that is your, so to say, payment to me. You are not paying. You are getting this free of cost. But pay in terms of likes, pay in terms of subscription, pay in terms of sharing, and pay in terms of hearing the videos. And ask your friends to hear the videos. So let viewers increase. So with that earnest request, my friends, because you are my ambassadors, you are my marketing engineers. So with that request, I thank you very much and a good day.